Hi, in this tutorial we are going to learn to generate a sequence of dates between two given dates. Then we will tweak around to generate a series of say weeks or 2 weeks, 7 days or 15 days or months and quarter, etc. We will also see how to compute whether a given date or range of dates belong to a leap year or non-leap year. We then will see how to compute week number for a given date. For example, there should be 52 weeks in non-leap year and 53 weeks in leap year. And a particular date might be, for example, week number 1 or week number 15, 52 or 53 and so forth. For all these computations, we are going to use R on Jupyter Notebook using Anaconda R kernel. You can see it over here. Alright, here actually is my notebook. But first thing first, how to generate a sequence of dates in R? Let's say we want to generate a sequence of dates between a beginning date and an ending date. For some reasons or the other, I'm going to use R's lubridate package, which is available on CRAN, the Comprehensive R Archive Network, and the package can be installed using this method here as is shown: install.packages, the package name and the repository address. Actually, I have commented it out, but you might have to remove this comment from this command before running it. Since I have already installed it, I can go through library and pass on the package name to load it in our environment. As we can see, usually we get warning messages because of some reasons or the other. You can hide them if you want. If you feel like this is a irritating one, actually you can hide them using options and -1 = -1, but this will hide all the warning messages. Sometimes warning messages could be really helpful in learning about what kind of error are we committing or something, but I mean, this kind of caution you have to take care of. But suppose if you're not looking for any kind of warning messages, like in this exercise, for example, I can run through this option. Okay, in the next step we are going to generate a series of weeks between two given dates. First, here we will have a starting date, and we are going to use YMD function of lubridate package. We pass on a particular date, say 1st January of 2017 I'm passing as the starting date, and I'm passing 31st March of 2017 as the ending date to the vector ending underscore date, and here starting underscore date. This one over here we could have done simply by passing weeks, which means 1 week itself, and it returns exactly the same results what we have got over here. But deliberately I wanted it to be done. The reason why, because suppose instead of 1 week, if I place something like 2 weeks over here, then I will get a series generated between this starting date and ending date, which is incremented by 2 weeks. And you can see it here, 1st of January, and then 15, and then 29, and then 12, and so forth. So exactly 2 weeks differences between each of those results. So just to summarize, I hope you got the idea. We use sequence function wherein we pass two arguments, starting date and the ending date, and also by what value you want these to get incremented, and hence the sequence generated. So we pass on these three arguments and we get the results. So having understood the above process, let's move to something different. Something like generating sequence of days. Herein what we do, we take up, instead of weeks like we have used earlier, we take days over here. So the same thing, sequence, starting date, ending date, two arguments, and by what increment should be there. So we are passing on days over here. That means we will get the dates generated, the series of dates generated between 1st January and 2017 to 31st March of 2017, which is incremented by each day, and we can see it over here. It goes up to 31st of January and then goes into February and then moves into March, April, sorry, March, yes, ends up to and ends at to March of 2017. So what if I wanted to generate a sequence of series incremented by 7 days? You got it right. Instead of days, I would pass 7 days over here. Essentially, it is same as equal to week, but I want you to learn this concept. The reason is because if instead of 7 days, I want to increase or I want to have an increment of sequence of dates by 5 days, I can't use weeks. I have to use something like 5 days or 3 days or say 9 days, 10 days and so forth. If it is 7 days or something like 15 or 14 days, you could have used weeks instead. So we will pass on starting date or original vector of a starting date and ending date, that's 31st March 2017, and then we increase the dates by 7 days. So we got these results, which are essentially the same as what we could have got using week. Alright, similarly we could have done something for months as well. Instead of passing days or the weeks, we could have passed months, and we'll get January, February and March, and of course the first dates will be shown up here. Why? Because the increment is by month. So this month's over, the next month starts, the next month starts, and so forth. What about by 3 months? Instead of passing on months, which is for 1 month, you could have passed 3 months, and that would have resulted into an increment between 2 dates by 3 months. And since we don't have 1st of April, that's why we don't see the result over here. But suppose if we use something like 2 months, we should get February as the result. And yes, oops, yes, as we pass for 2 months, here we can see we got result for January and March. So increment by 2 months. So let's get back to our 3 months thing first. Alright, the idea over here is when we are saying 3 months, basically it's like a quarter of a year, isn't it? It's the same as the quarter. So instead of typing 3 months wherever we are increasing our date range by 3 months, we should have written quarters instead. And it does the same thing what result we got over here, wherein what we are doing, we are passing starting date again, the ending date, and by quarters, and we got it. I hope this idea gives you a fair idea about populating series of dates. Now let's work on finding which week number is it given a date, something like that. In this direction, we want to find, if we pass on a date, what week is it. And to run through this exercise, let's first create a date series, basically a sample of the dates, and do the rest exercise. So we take up 1st January of 2010 as the first date, and 31st December of 2016 as the ending date. That means essentially what we are doing over here, we want to populate a series between 6 years. Why do we want this? The reason is because I earlier explained you a non-leap year will have 52 weeks, whereas a leap year will have 53 weeks, and we want to see in our computation both as a clear difference. Like, we don't want to get confused, we just want to see whether we are getting the result exactly what we think should be or not. So we created a vector sample dates, passed on these two dates vector, and increased by each day. We can see the head and tail just to get a confirmation whether the population generated over here is exactly the same what we assumed or not. So head tells me that I started with 1st January of 2010, which should be the case. Yes, it is. And then ends at 31st December of 2016. Yes, this is the case again. So total number of days in those 6 years, basically 2557. There may be some leap years and there may be some non-leap years. As we know, yes, it could be the case. Let's find them. So to find leap year, whether a particular year is a leap year or not, we will write a small function, although it's bit different from the exercise what we have started with, but let's look into like what we want to do using this function. A leap year, we define a function wherein we pass on a year value and then we compute. The basic idea over here is if a year is divided by 4 and divided by 100 and divided by 400, it is a leap year. So after running this function, we passed on, say, year 2017, whether it is a leap year or not. So if else condition says leap year, take the function, pass on this value, and if it is true, print this is a leap year, otherwise print this is not leap year. Simple. So 2017 basically is not a leap year. Okay, now we know sample data of dates. Let's check which years are leap years and non-leap years. So what we do, unique, we use a function unique wherein we pass sample dates data set what we have just created, and we retrieve only year information out of it. That year function on the data will actually return the years of each of the dates, and we just wanted to have only unique years. And then these unique years basically are passed to the function we just have created up there, a leap year, to get an information whether a particular year in the data set was a leap year or not. So we can see 2012 basically is a leap year, and 2016 basically is a leap year, and rest are not. So within the lubridate library, we have the function ymd basically, which converts any given date into year, month and date format, and then when we pass on to another function within lubridate week, basically returns the number of that week for a particular date. So over here we can see 16th March of 2014 basically is week number 11, and then this, and 1st January of 2014 basically is obviously week number 1. Similarly, we could have done the same thing for our day and week functions from the lubridate package. Here what we are doing basically, we are passing on only top 10 rows of the sample dates, converting them into year, month and date format, and then retrieving which day basically it was. So the first obviously is the first day, second date is obviously the second date, and so forth up to 10th, because we are passing only 10 rows of data into it, and then it returns you back the week value for that particular day. So first day obviously first week, second day obviously first week, up to 7th. Obviously these whole 7 numbers belong to the same group, same week number 1, and then second week and so forth. So this looks good. As an alternate, instead of using lubridate package, we could have done the same thing using base package function itself. As .POSIX basically converts date into numbers, and we pass on the dates data set to it and store it into another vector called dt, for example, and then to retrieve which day basically each one of the passed on values is, and then we can see like dt and y day plus 1 basically what happens like if we run through only this command, basically it returns values starting from 0. So instead of starting from 0 as index, we increment it by 1, and then we can see like it's first day, second day, third day, and so forth. And like if we want to see the total values or more than the 6 results from the header function, actually we could have seen for more by passing something like let's say for 25 such dates. Okay, so here it is, and confirms exactly the dates in the dataset, the number of days for that. And then to get the number of week for each of these date, we will do this thing wherein we divide the days by 77. If it is divisible by 77, count it, and instead of making it index as 0, add 1 to it so that index starts at 1, and you can see like 7 days. They are 111, week number 1, and then week number 2 for another 7 dates, and then week number 3, and so forth. And here, since we have taken only 50 values, so obviously 7 into 7, 49 plus 1. And this is the complete data set passed on and retrieved the week numbers. So we can see, we can observe here we have leap year, here we have leap year, and this one, I mean this is, yeah, okay. So this is all about working with dates and days, week number, etc. in R. I hope you got to learn something. If you have any question, please write into the comment, like the video, subscribe it, share it with your friends, and I'll come back with some more videos onto it. Have a nice time. Bye.